Okay, we have been working to try to solve this integral right here, cosine of the square root of x dx. And right now we left off down here, and we were dealing with this integral right here, and we said it equals minus y squared times the cosine of y plus this integral here, and finally we got an expression for this. It's right here. So let's just first backtrack, and we're going to say that this integral here, integral of y squared times the sine of y dy will equal this, minus y squared times the cosine of y plus 2 times this integral, and that came out to be equal to this. So we'll have plus 2y times the sine of y plus 2 times the cosine of y. Okay, now what we have to do, we had to remember what is y, because we've made several substitutions as we've been going along here. And we go back to the very top, and we had this substitution for y. Y equals the square root of x. So let's get that into here. And also remember that we had this integral, the one we're interested in, was equal to this plus this integral here, but we determined that this integral right here was equal to this one here when we made this substitution. So again, let's get things expressed in terms of x again. So this is going to be minus y squared. This would be minus x times the cosine of x plus 2, this is a square root of x, and this is going to be the square root of x. Let's just start this over. Y equals the square root of x. That was our substitution. So let's see, we're going to have minus x times the cosine of the square root of x plus 2 times the square root of x times the sine of the square root of x plus 2 times cosine of the square root of x. That's this integral here, substituting what x is. X equals, or y equals x to the 1/2 power. So putting that into here, minus x times the cosine of the square root of x plus 2 times the square root of x times the sine of the square root of x plus 2 times the cosine of the square root of x. Now, backtrack some more. Remember what we had. This integral here, we made our substitution as this integral. We solved that. We put our substitution in, we have this. So what we can say is this integral right here is this. This integral here is this. Again, so there's no confusion. We had this integral, we made a substitution, and we got it into this integral. We solved this integral here. We got this expression. So now we're backtracking. And we're saying, well, if we make our substitution, then we would have the answer for this integral. And that's this right here, after we made our substitution that y equals the square root of x. Now we go back. This integral right here goes from when we took this step here. So finally we have this integral here equals this plus this integral. Or that would be this term here, x times the cosine of x, plus all of these terms right here. So we're going to have the integral of the cosine of the square root of x dx equals this term plus all of these terms. So that's x times the cosine of the square root of x minus x times the cosine of the square root of x plus 2 times the square root of x times the sine of the square root of x plus 2 times the cosine of the square root of x. It looks like these are going to cancel. So we're left with 2x times the sine of the square root of x plus 2 times the cosine of the square root of x plus an arbitrary constant. So I hope it wasn't too confusing. We tried to take it step by step. And as you can see, there's no tricks involved. It was just starting out saying we have no choice. We have to call this u and this dv. We do that, and we have this. We treat this with a u du type substitution, and we get this integral. And right away we realize this we should be able to solve integrating by parts. We had to do it 2 times around, and finally got this here. So then we just had to backtrack with our original substitutions and finally get back to our original integral. So again, hope it wasn't too confusing. We should try to go through it, like I say, step by step. And that's really is the biggest trick of this whole technique here is you might end up with multiple steps and making multiple substitutions. So keep careful track of everything as you go along, so when you finally get the way you have completed your last integral, then you just backtrack, put your substitutions in, and you should get the answer to the original integral that you were working with. Okay, that's it for this problem. Come back, join us for some more videos, and we'll see if we can solve some more problems.